Hey guys, we are rules about how we combine things. Like if I have b to the 2 times b to the 3, that would be b to the what? To the what? To the 5. What do we do when we multiply terms? What happens to their exponents? They add them. So that's b to the 5th. And you can see that because b squared is what? B times, and b cubed is b times b times b, and then that's b 1, 2, 3, 4, 5. You see, it makes sense. So that's one thing that you need, and we could sort of say that as b to the a times b to the c is equal to b to the what? A plus c. You know that, right? And then similarly, if I had b to the a over b to the c, that's equal to b to the what? A minus c, because that's down there. All right. What you also need to know is, and what you also know is, b to the minus 1 is equal to what?
1 over b.
1 over b. And if I have 1 over b to the minus 1, that's equal to what? B. All right. So you see that negative, you can just put it in the opposite spot and then take away the negative. Does that make sense? Okay, so you know that. And then there's one more. Like if I have b raised to the a and then raised to the c, this is a power to a power. How does that work? It's b to the what?
AC.
AC. Right? It's b to the a, b to the c. So you understand all those rules of exponents. So you know almost everything that you need to know. Okay, you need to know everything that you need to know. Okay, rational exponents. What does rational mean? What is the key part of rational?
It's ratio.
Ratio. Okay, so what happens when the exponent is a ratio? All right, now this is what I want you to think. If you have, let me just give you a real example. The square root of 4, that's equal to 4 to the what power? 1/2. Okay, 1/2. So you imagine there's a 2 there, all right? So if I have an index of b, the b root of a, what is that equal to? A to the 1 over b. A raised to the 1 over b. Okay? So if I had the cube root of 8, what is that equal to?
8 to the 1/3.
8 to the 1/3. Okay? And 8 to the 1/3 is equal to what? 2. Okay? But what I want you to do is put 8 in your calculator and raise it to the 1/3. What do you get? What? Okay. So that way you can see if you have something like the 6th root of 64, and let's say that's not easy to do in your head, how would you do it in the calculator?
Raise 64 to
64 to the 1 over 6, right?
You can
Okay.
do this. You can do.
What?
You can do the 6 root of 64 without having to do 64 to the 6 to the 1.
So it has, it'll do an nth root?
Mm-hmm.
Okay. So some that's a good point, Tanner. Some calculators will, all right? But I want you to understand how to do this with something that just has a raise to the power. So if you say 64 to the 1/6, what do you get? 2, okay? That's equal to 2. Okay, so let's see different things that we can use this for. So we're going to start working some problems, okay? Like if I ask you to evaluate 16 to the minus 1/4 without a calculator, what would that be?
It'll be 1 over 16 to the 1/4.
Yeah, first of all, Braden, good intuition. Deal with the negative. 1 over 16 to the 1/4. Now tell me just by thinking, what is the 4th root of 16? 2. Because let's try it. Count with me. 2,
4, 8, 16.
2, 4, 8, 16. 2 multiplied together 4 times gives you 16. So the answer is 1/2. Good work, Braden, on seeing to deal with that negative first. That's really good. Okay. Here's another way that you could work it. 16 to the minus, or let's see. 16 raised to the minus 1/4 is equal to 2 to the 4th. 2 to the 4th is 16, right? Raised to the minus 1/4, okay? And that is equal to 2 to the minus 1, which is equal to 1/2. Does that make sense? And I think did I do that right? Yeah. Does that make sense? Okay. Another way to do it. Okay, let's try this one. 243 to the 3/5. A way that you should do it is you should break it up into 2 parts. This would be 243 raised to the what first?
Third.
Okay, that's not wrong, Braden. But if you do the third first, it's going to blow up, and then you're going to lose an ability to see if you can do the root part. So you want to see if you can do the root part first. So you would say 243 to the what? 1/5, and then that whole thing what? Cube. So is there anything multiplied 5 times together that will give you 343? If you were going to guess, you know it's not going to be 2, so what would be another good thing to guess? If not 2, what would you guess maybe? 3. So 3 times 3 is 9, 27. What comes after that, Tanner? 27 times 3. You got a calculator in your hand, man? 27 times 3 is?
81.
What?
81.
81 times 3 is? 243. So this is 3, right? 3. 243 to the 1/5 is 3, and then we cube the 3, and that's what? 27. This is kind of straightforward. So what you got to see there is if you have a full ratio of b raised to the m over n, how would I put that in radical form? What goes under the radical? B. Okay, you're right, but you're already getting to the answer, so I want to make sure people understand what you understand. So B, what goes out here? N, and then what power is B raised to? Yeah, okay, and that's what Tanner said right off, but I want to make sure everybody was following that, okay? So let's do some real examples. Let's say I have x to the 1/5 times x to the 7/5. That would be x to the what? Don't tell me the answer, tell me the step. X to the what?
X to the 8.
No, tell me the step. What do I do with those?
You add the
Okay, so tell me what it is.
x to the 8.
Not the answer, tell me the step. What do I do with these?
X.
Okay, so what do I write here?
X 1/5.
What?
X,
X
1/5 plus 7.
Plus 7/5. All right? And that's equal to x to the what? 8/5. And that you were trying to give me the answer, but I want you to put this step in. Okay, the answer is x to the 8/5. So y to the 3/4 is equal to what? I mean, y to the negative 3/4 is equal to what? 1 over y to the 3/4. Okay, and what is the problem with that? That is like 1 over the 4th root of what?
Y cube.
And why can I not stop here?
Because
It's a radical.
There's a radical in the denominator. Now think carefully. What do I need to multiply this by to get the denominator? And think carefully.
1.
The 4th root of y. Okay, because I got y cubed, now I've got y1, so that would become y to the fourth, and I would have the fourth root of y to the fourth. If I multiply the denominator by the fourth root of y, what do I have to multiply the numerator by? Fourth root of y. So then the answer is the fourth root of y over the fourth root of y to the fourth is y. And that is a beautiful answer. That is a beautiful answer. Okay? All right, let's keep going. Let's keep going. If I have the eighth root of 81 over the sixth root of 3, what would this be? 81 to the what? 1/8 over 3 to the what?
1/6.
Okay. As that's written, can I combine it? What? I can only use that subtraction rule if what? If the numbers are what? The same. Are they the same?
No, it's no solution.
So what do I do?
Leave it.
You what?
It's no solution.
No. Do I run from the room crying like a little child? No. Do I fold up like a cheap lawn chair? No.
Minus
Tell me, what do you wish? You wish that that 81 was a what?
a 3.
Okay. So, we have 3 to the 1/6. What do I wish 81 was? A what? A 3. Can I write 81 as 3 to the something?
Yes.
3 to the what?
4.
3 to the 4. And then what do I still have out here? 1/8. So 81 is 3 to the 4th. I haven't changed anything, right? It's like 81 to the 1/8 is 3 to the 4th to the 1/8. What is 3 to the 4 raised to the 1/8? 3 to the what? Power to a power, what do I do?
Multiply.
What? Multiply. 4/8 is what?
1/2.
1/2 over 3 to the 1/6. I got my what? I got my wish. I got a 3 here and a 3 here. So then I can say this is 3 raised to the what? Not plus,
Minus.
minus 1/6. Okay? And so then this would be 3, this would be 3/6.
To the 1/3.
Yeah, 3/6 minus 1/6 is 2/6, which you saw was 1/3. Right? See that? A lot of fun this stuff is, isn't it? A lot of fun. Okay? Let's try to reduce this. The fourth root of 9z squared. How would I rewrite this in exponential form?
9c
Raised to the what?
to the 4th.
1/4. Okay, this would be 9 raised to what power? What?
No.
9 raised to the 4th.
1/4 times z raised to the what?
2 over 4.
2 over 4. So the z is going to be z to the 1/2, right? Now 9 to the 1/4, I don't want to leave that because there's kind of like something in there. I could rewrite 9 as a what? 3 squared, right? Raised to the what? 1/4. Do you see 9 becomes 3 squared? Now that becomes 3 to the what? To the 1/2 times z to the 1/2. And then what is that?
Square root of 3z.
The square root of 3z. Do you see how that works? Is this good stuff? Okay. All right. Now this is another interesting one. Let's say I have the square root of m minus 1 over the square root of m plus 1. What is the problem with that? What do I have?
Radical.
Radical in the denominator. Well, would it help? Don't write this down, but would it help for me to do this?
Yeah, you have to do,
No, because it would fix this, but then it'd create a problem there.
so you have to do n minus 1.
Okay, well, okay, so let's say down here, I want plus 1, and then instead of plus the square root of m, I need what?
Minus root of.
Minus the square root of m. And if I multiply the denominator by that, I got to multiply the what by that? The numerator. Square root of m plus 1. So I've really multiplied by 1. I haven't changed anything, but it's going to fix my problem. So the square root of m times minus the square root of m is going to be what? Minus m, right? And then I've got minus the square root of m plus the square root of m. That goes away, and then I'm left with what? Plus 1. Does that make sense? Okay. What do I have up here? Square root, and I'm FOILing, right? Square root of m times the square root of m is m, and then plus the square root of m,
Minus the square root.
and then minus the square root of m, and then minus 1. Those make 0, so I have m minus 1 over minus m plus 1.
Why isn't the top minus it as well? If you're
First
multiplying.
Okay, let's look. Did I make a mistake here? Oh, it's minus the square root of m. Okay, you're right. I made a mistake. Thank you, thank you, thank you. Okay. Thank you, thank you, thank you. So this down here we said was minus m plus 1. That's right. But then the square root of m times the square root of m negative is what? Minus m. Okay? Does that make sense? And then I add, let's say, I am going to add the square root of m, so plus the square root of m. And then I am going to minus times a minus becomes plus the square root of m. And then I'm going to have minus 1. Does that look good? So I have minus m plus 2 on the square root of m minus 1 over minus m plus 1. What's really nice about this, I got rid of the radical out of the denominator, which is what we were trying to do. Okay? One more and I'll give you the homework. What if I have x to the 4/3, x to the 2/3 over x to the 1/3? Tell me what you would do. That would be x raised to the what?
8.
Don't tell me the answer. Tell me the step.
4/3 plus 2/3 minus 1/3.
4/3 plus 2/3 minus 1/3. Okay. So that's going to be 4 plus 2 is 6, minus 1 is 5/3. X to the 5/3 is a great answer. That, my friend, is how you do rational exponents. We are done. Okay. Homework is